My properties of exponents day 2. We're going to pick up where we left off yesterday. Today we incorporate a few more of those geometric shapes that we've so conveniently forgot about over the last year or so. But their equations or solving them makes it useful for us to actually simplify these radicals. So that's why we'll be using them as part of our demonstration for today. Please note that anything raised to the 0 power is 1, so I would be distributing the 0 to all of these values here, which means that regardless of which one of these it is, they are all 0. So this is a very dramatic demonstration of the 0 property. Anything raised to the 0 power is 1. The expression for the area is 1/2 base times height, or if you so desire, base times height divided by 2. Area equals a to the third b times 2a to the third b to the sixth times 1/2, or divided by 2. We'll start by simplifying our a's, and that becomes a to the sixth. We'll continue by simplifying our b's, that's a 1, and 6 is 7, b to the 7th, and we will finish by simplifying our numbers, and the area is a to the 6th, b to the 7th power. The volume for this is going to be area of the base times the height. Since the base is a circle, that's going to be pi r squared times h. So we'll go ahead and fill in all of the values that we know. Pi times r squared, which is going to be 5x to the 8th y to the 3rd squared, times 3x to the negative 2 y to the 0 power. First thing I'm going to do here is distribute to all of the exponents on the inside. Please remember that the 5 has a 1 on it. Volume equals pi times 25, that's 5 squared, x to the 16th power, y to the 6th power, times 3, and I'm going to go ahead and draw my fraction bar, moving my negative exponent to the bottom, x squared. Anything raised to the 0 power is 1, so I'm not going to bother writing that. 3 times 25 is 75, so my volume is going to be 75 pi. X to the 14th, subtract your x's, y to the 6th. Question number 4. The volume of a rectangular prism. Rectangular prism, volume equals length times width times height. So we're going to have x minus 2, x minus 2, and 6x plus 2. You'll notice here that this is a perfect square trinomial, so that's going to be x squared minus 4x plus 4, and we're going to go ahead and multiply that by 6x plus 2. Distributing all the way through is going to give me 6x to the third minus 24x squared plus 24x plus 2x squared minus 8x plus 8. Combining like terms and rewriting it in appropriate form with the highest degrees first. We're going to say volume equals 6x to the third minus 22x squared plus 16x plus 8. Writing the expression of the radius of a circle if the area of the circle is this. So area equals pi r squared. So we're going to fill in the value that we know. 4 pi times x to the 8th y squared equals pi r squared. If we divide out our pi to both sides, we get rid of that tricky little number, and radius squared is going to equal 4x to the 8th y squared. In order to get rid of the square, we have to square root. So now we get radius equals 2 x to the 4th y. Let's investigate why that is, because I'm going to rewrite it as 4 times x to the 8th times y squared. I'm going to look at each one individually. Using a tree diagram, that's 2 and 2. Perfect square 2 comes out. I'm going to go ahead and write my x's out in a list like this. I'm going to circle groups of 2 of them, and you'll notice I can circle 4 groups of them, which is why it's x to the 4th, and I will list out my y's as well, and that's why it turns out to be y. A lot more to come on this later on in the week. If the length of the rectangle is this and the area is that, we need to find the width. So area equals length times width. So it's going to be 21h to the 4th gf to the 0 equals 7h to the 3rd gf to the negative 2 times w. So we'll go ahead and take a look at this problem because it's a little bit interesting. What we're going to do is we're going to divide this number, remember it's just a single number, over to the other side. H to the 3rd gf to the negative 2. Same thing over here, 7h to the 3rd gf to the negative 2. I'm going to make 2 changes before moving on here. The first change I'm going to make is right here. F to the 0 power is 1, so I'm not going to bother writing that again. I notice there's a negative exponent, so I'm going to be moving that individual value up to the top in my next step. So it's 21h to the 4th g times f squared divided by 7h to the 3rd, and there's a g left down there. Simplifying the numbers, I get 3. Simplifying the h's, I get 1h. There are more h's on the top, so that's why I leave it on top. These cancel out, and f squared has nothing to simplify with. There's my final answer. Alright, the next step we're going to take is we're going to start solving expressions, or solving equations for x, using the properties of exponents that you already are familiar with. Notice that all of the bases are the same. If they aren't, such as over here in all of these problems, you must first make them the same, and then you can solve for the missing value. Because I know that my bases are the same and they're being multiplied together, I'm going to add my exponents. So what I'm going to do here is I'm going to rewrite this expression using properties of exponents without the base of the exponents. Subtracting 7 to both sides, x equals negative 2. If you're ever in doubt about this, please put it right back in and solve it. Notice that I would move the first 2 to the negative 2 power to the bottom, and 7 minus 2 is 5, 2 to the 5th power. Alright, number 8. What I'm going to do here is I'm going to distribute this in, and I get 12 to the 5x power equals 12 to the 100 power. The bases are the same, so I'll drop them out. 5x equals 100, divide by 5, and my final answer is x equals 20. Number 9, we're looking at 2 variables here, but you'll notice that one of the variables automatically cancels, so it's a simple distractor problem. We don't need to deal with it. So what's left is 5 to the negative 2x equals 5 to the 5th. Now notice I don't bother moving it to the bottom because I already recognize that both of these are the same, and in fact it's a lot easier to solve for if it stays on top. So drop your bases, rewrite the exponents, and use your properties to solve them. So that means x to the negative x equals negative 5/2. Alright, now we're getting into some problems where the bases have changed. They are no longer the same. So I'm going to look at the smaller of the two bases. I'm going to look for a way to turn the large number into the smaller one. And it just so happens that it's 5. So 2 to the 2x plus 1 equals 2 to the 5th. Now it's identical to the one prior. 2x plus 1 equals 5. Subtract your 1 and divide by 2. And that gives you x equals 2. Right here, again, I'm going to change the 27 into a 3, and that turns out to be 3. So it's going to be 3 to the 4th power. Now be careful. Be careful because there's already something in this exponent. So it's going to be 3 to the 3rd power times whatever was already up there. And you'll see that that happens a lot moving forward from here. So please make sure that when you change this, you multiply that new exponent by what was already there. So 4 equals 3x minus 3. Drop your exponents, add 3 to both sides, and I get 7/3 equals x. Alright, increasing in difficulty. Notice that the number 64 doesn't go to 16, so now I'm going to have to look at it from a different point of view. Both of these numbers reduce to a base that is the same, and both of these numbers have a common base of 2. So in this one, it's 2 to the 4th power. Remember, you're going to multiply that by the number that's already there. And this one is going to be 2 to the 6th power. You could have also used 4 squared, and 4 to the 3rd power would have gotten you that as well. So it's going to be 4x plus 8 equals 6. Subtract your 8, and you get negative 2/4, which reduces to negative 1/2. Now we're going to incorporate some fractions. Don't be overwhelmed by the fractions. Don't be intimidated by the fractions. Just realize what happened to the exponent to get it into the fraction. Remember, it was negative when it was a whole number. That's what happened before it got moved downstairs. So we're going to rewrite this as 5 to the negative 2 power. And that's multiplied by 2x. Okay? So it's a little bit of backwards thinking here. Okay, you got to really understand what it took to put this number in fraction form. And remember, that was a negative exponent. Remember, the idea here is that I'm getting the bases the same, so that's why I automatically changed that. You could have changed this to 5 squared and then moved it up, but I combined those two steps together. Multiply these two numbers together, and I get negative 4x equals x minus 5. So I'm going to subtract my x here to get negative 5x equals negative 5. Divide out my 5's, and x equals 1. Let's practice that fraction again. Think about what it takes to turn this whole number into a fraction. So I'm going to change this base to a 2, and that's going to be 2 to the 3rd power. But I needed to go back up to the top again, so thinking backwards, I've got to make that to the negative 3 power. So it looks like this. 2 to the negative 3 power times 3x. Drop your bases, multiply these together. X minus 1 equals negative 9x. Subtract your x to the other side, and I get negative 10. So dividing it back out again, x equals 1/10. Oh, sorry, I wrote that wrong. That's why my notes didn't match up. Negative 1/10. Moving on. Again, the most tricky of them all is to give you one where you have to change both bases. Alright, this one's your 2. And remember, this fraction became a fraction because the exponent at the beginning was negative. So this is going to be 2 to the 4th power times 2x plus 1. Remember to multiply it by what's already up there. and that's going to be less than or equal to 2 to the negative 5th power. We drop it and we leave the exponent, or we leave the inequality just the same, so that's going to be 8x plus 4 less than or equal to negative 5. Subtract your 4 to both sides and you get negative 9 and 8x less than or equal to negative 9. So x has to be less than or equal to negative 9 over 8. Utilize your properties of exponents. Understand what it takes to change a whole number into a fraction and vice versa. Remember that being a negative, and you'll be okay with problems like this.